Welcome to the Sparklink Podcast, where you will meet young minds making a large impact one idea at a time. This is Ashna Reddy, your host. As reported by the NCBI, about 40% of people aged 65 or older have age-associated memory impairment. In the United States alone, that is about 16 million people. Alzheimer's News Today reported that there are approximately 44 million people worldwide living with Alzheimer's disease or related form of dementia. In addition, the CDC, or Center of Disease Control and Prevention, reported in 2014 there were approximately 2.5 million TBI, or traumatic brain injury-related ED visits in the U.S., including over 812,000 among children, which can lead to impairments related to thinking, memory, movement, sensation, and emotional functioning. These are just some statistics that lead to problems including slow learning and memory loss. Iain McIntyre, the co-founder of Humm, which is funded by UC Berkeley as part of the Berkeley Skydeck program, which is a research university accelerator that helps to launch startups, created Humm to solve these types of issues. Essentially, Humm's solution is to enhance activity through targeted delivery of stimulus, aka neuromodulation, into the prefrontal cortex located directly behind the forehead, where different brainwave patterns have been linked to essential cognitive functions such as learning, decision-making, and problem-solving. To get a bit of a background, Ian explains how he got interested in neuromodulation and where he and his team's research took them.
My co-founder, Tim, was going to be a medical doctor. Tim invited me to be one of the participants in some research he was doing. That research was using powerful magnets on people with spinal cord injuries to actually help them walk again. I was a healthy control subject. It involved putting a big powerful magnet on your forehead and other parts of your head too, counting down from 30, a bit like torture, and then actually zapping the brain with a really strong electromagnetic field. A loud zap would happen and my arm or my leg would run away from me. I lost control of it. And it was fascinating introduction to this incredible technology that we call neuromodulation. To me, it was fascinating because I didn't realize that you could actually use technology to so precisely control the experience of reality and people's feelings and thoughts and cognitive skills. Like we could make people learn faster, or we could make people feel drunk with this kind of technology. And that was super exciting. We started reading papers and experimenting with open source tech, and we spent the next 10 years doing that before we ended up starting our own company, commercializing a particular part of the research that had become really exciting. And we were in Western Australia, working with a Western Australian lab, and ended up shifting it all over to UC Berkeley about a year and a half ago, when UC Berkeley and UCSF wanted to do research with us, and UC Berkeley offered to fund us through the Berkeley Skydeck program. And here we are, launching our product, which helps people learn faster, particularly older people, and doing research with UCSF.
Now, to understand Humm's actual product, Ian went ahead and explained what it looks like and what the interesting science behind it is.
The device is just this little patch. It looks a bit like a big Band-Aid made out of fabric. Inside of it is a circuit and a battery, which puts electricity through those little pads that are stuck onto your forehead. They're called electrodes. So they're made of like a sticky substance which just sticks to your forehead, but it conducts electricity. And what the circuit is doing is it's flipping a electrical signal backwards and forwards in something, alternating current. It's a really tiny amount of electricity. It's like 4,000 or 5,000 times less electricity than actually is in your brain already at any moment. And it's actually a really tiny amount of energy too. It's something like 5,000 or 6,000 times less than the amount of energy that gets dissipated in your brain when you put your phone against your head for a 15-minute call. What we do is we put this tiny amount of electricity in, and what it's doing is it's actually training neurons. It's an effect called entrainment, entrainment. It's causing an effect like dropping a stone in the middle of a puddle where there's a ripple. So the alternating current is at a frequency, or like a number of times that it's flipping backwards and forwards. And that frequency is 6 hertz, which sits within a particular group of brain electricity waves called theta. When we boost that theta by putting that current into the brain, and when we encourage neurons throughout the brain to fire at that frequency, or that 6 hertz frequency, what we're doing is we're dropping the stone in the middle of the pond. We're causing a ripple effect where neurons throughout the brain just become stuck together into a circuit. So they're all firing at the same frequency, and they're able to transfer information better between each other.
And here's the immediate effect on brain function when using the product.
You're able to process more information, or do what we call working memory capacity improvement. What that means is that when we test people using cognitive neuroscience batteries that we use in neuroscience university studies, we find that people can actually remember more digits at any second. So they can hold more information in their like working memory, short-term memory. And what that means is that people can, when they come to a difficult activity, learn that activity faster because they can process more information. They can store that information faster too, so they can learn a skill or a body of knowledge faster. But also they can be more adaptive and creative in challenging situations. They can multitask faster, better by switching contexts with more information available to them. And then they can also just focus easier and stay focused easier because distractions are easy to filter out when you've got more RAM in your brain.
Since some of the capabilities of the brain are improved through the use of the product, I wanted to know if there were any permanent or long-lasting changes to the brain as a result.
Neuromodulation stuff doesn't cause any long-term effects. It doesn't create any kind of resistivity or like adjustment where people don't feel the full effects because their brain adjusts. It doesn't cause any kind of addiction, and it doesn't actually cause any changes beyond at most a day after using the product, and typically more like several hours.
Humm, having the technology to affect the brain, made me wonder which groups of people they market their product to, since their product, as Ian mentioned, may seem scary to try, but has a lot of advantages and no long-lasting changes biologically.
Our first product was designed for students to learn faster. Our second product was for esports athletes, people who play computer games professionally and competing for millions of dollars. And then our third product, the thing that we're doing now, which is based on the learning from those almost 2 years, is for older people who are actually noticing that their memory is deteriorating, that natural aging process.
Now, it is obvious why Ian marketed his product to students and elderly people, because students are constantly taking tests to prove they understand material, which requires recall, aka memory, and the elderly age group is more likely to have age-related memory impairment. But why did Ian market his product to esports players?
So we looked for a place where we could have a quick win, like somewhere where there was a strong emotional and financial reason for people to use our product, and where we could also get really good results, like improving that activity. The cool thing about esports is cognitive athletics. It's basically sitting at a computer, not using your body, but rather using your brain to beat someone in something. We could give people slightly better working memory, the thing that we improve. It's a bit like the RAM of a computer, and they could faster adapt to the changing situations in games and beat people better, basically.
Ian will not be advertising, marketing, or giving Humm's products to those that are under the age of 20, and here's his reasoning.
We're intentionally not letting it go there to start with for a couple of reasons. The most important is that there just isn't enough clinical data on children to measure how this affects development. And so we don't want to work with developing brains because we don't want to be doing something that hasn't been like very solidly proved in a huge quantity of data. We have much more data for healthy adults because that's where this kind of novel style research, newer research starts. We're very confident it's safe and healthy for people above the age of 18. We just don't have the data to say that it is safe and healthy for people under 18. We have talked to lots of scientists and don't think that there's any reason to think that it could be dangerous at all for anyone but babies who have very thin skulls. But we just don't want to be even opening the door to the perception that we're cowboys or like in some way testing with the public rather than the right way, which is the clinical studies. But then also, I think there are strong ethical concerns for the use of this in schools and things like that. We want to be part of coming to a solution for those like ethical questions. We're going to do research with unhealthy children pretty soon. We already have a couple of clinical pathways lined up for investigating how to help children who have traumatic brain injuries to get better results at school. But yeah, we don't want to be opening the door to any of those ethical concerns either about like what happens when one kid can afford this and one kid can't. Working memory has actually been found to be a better predictor of success in education and life in general than IQ. We actually, if we can give someone 20% improved working memory, which is what we found in our clinical study in a school, creates a massive bias within the education system. So we're kind of wanting to avoid that to start with too.
Throughout the solution process, Ian and his team faced many challenges, and Ian went ahead and shared some of them.
This is a technology that's been around for a long time. This neuromodulation technology. It's been FDA approved for 30 years in some of the products. It's been studied in labs for 50 years, maybe more, but it's really difficult to get it out of the lab. It's really scary to people to electrocute their brains, like understandably, and it seems like magic. So not only are people worried about doing it, but they don't really believe it when they first hear about it. And so although there are these, expensive devices in labs that are getting good results, they're really difficult to use. They're really scary for people to put on. They're really expensive to buy. And people don't really have the education to kind of understand how the scientists are explaining they work. So what we're doing is really difficult. We're trying to take this very scientific, scary, and hard to use and expensive technology out of the lab and put it into a package and give it to people in a way where it's effective. It commercializes the good parts of the research rather than the stuff that didn't work, but also where it's, easy enough to use and easy enough to understand and desirable enough that people will actually get benefit out of that.
As Ian had mentioned, there are other companies using neuromodulation to do very similar things to the brain. So I had to ask how Humm differentiates itself from them.
So one, we're a lot cheaper per use. We've done a lot of work on the actual technology to get it to the point where it's not like buying a coffee machine. It's like buying a coffee. Our device is about $5 per use at the moment and will come down over time instead of being $500 or $600 just to get the device. And the second is that it's much easier to use. So it's about as simple as putting on a Band-Aid, and you can carry them around in your pocket in large quantities, rather than there being like big caps and headsets that take 10 minutes to set up often and require like wetting sponges and things like that. So we've done a lot of work on making it very easy to use and intuitive. And then the third thing is that we are novel science as well. So there's not been a device that's commercialized the exact science that we've done before. There have been devices that have done other forms of neurostimulation, other placements of the electrodes and other amounts of electricity and types of electricity, but no one has ever done this learning speed improvement using this frontal stimulation method that we use.
Because of how Humm differentiates itself, they have landed a partnership with the US Air Force for this reason.
So the Air Force have this big drive to improve the quality of their training and lower the costs of their training. So we entered into a pipeline for their kind of uncovering innovative new things that can help with pilot training, similar to other options like VR training. They've thought about brain stimulation before. DARPA has actually done some really good work, the kind of United States military's advanced research group. So they were familiar with the technology, but we've got this new form factor and device, which is really easy to use, that could be much more scalable. And also the science that we've done and that we are relying on from other labs as well, it seems really promising for actually improving the ability of pilots and pilots in training to learn faster. So what we've done is we've given them 1,000 patches of ours to investigate doing a clinical trial so that we can measure how much our device improves pilot training, then figure out like how could we actually implement it on a broader scale.
Humm has distributed its product within many different consumer groups, and here's what Ian and his team are doing next.
So we're at the point now where we've got finished product. It doesn't look pretty. So we're still in the product development phase and figuring out, does it have this kind of button or this kind of button? Is it made of this kind of material or this kind of material? So we've got about 1,000 pre-orders from customers, and in the future we'll be raising a lot more money because there's a lot of development and stuff of future products to come. But yeah, that's where we're at.
And here's Humm's overall vision on how they hope to impact the world.
So we started the company just being really excited about the ability to help people learn faster. And I think that makes sense, right? Like there's just an obvious answer to if you can improve the ability of people to learn things faster, that's really exciting for lots of people. But I'm actually really grateful to have ended up in this place where we've ended up, where the data led us that this would be most useful, because what we're doing is we're fixing a problem that every human who's ever lived has just accepted. But it is a problem. And that problem is that from the age of 20, we just start being able to not learn as fast as we could anymore. We call that healthy aging. And I think that's bullshit. I mean, it's you can understand why it's happened. We've all gone through, tens of thousands of years of humanity where that's just been a thing we've had to accept. But as soon as the technology can bring us back to that childlike ability to learn, to give us that better memory that we were able to access when we were able to learn things with joy when we were children, rather than struggling to process information, which is what we just come to accept the older we get. We shouldn't have to accept that. We should be able to be liberated and live our lives to the capacity that technology allows us to do. And so, yeah, I'm really excited for that. I think it's particularly personally exciting for myself and my co-founders because we have parents who are getting older and grandparents who have suffered from dementia. And this technology doesn't just have the capacity to help healthy people where we're starting, but also could be an incredibly powerful, potentially even solution for Alzheimer's and those kinds of things with much more research and development.
For any of you interested in starting something, here is Ian's advice.
It's bloody hard. Don't do it unless you're really, really passionate about the thing that you're building and why you're building it. We have seen many startups around us in the accelerators and other ecosystems that we've been part of fall apart because it is just so hard and it takes such a toll. And there's no guarantees, especially if you're doing something like a moonshot that's really difficult and has a lot of potential to help people rather than just, a software that can assist a company improve its processes by 10%. There's no guarantee that you'll have a big, financial return, nor that it'll be healthy for you. There's a lot of stress involved. You need to find the right people to be with you, and you need to find a problem that you really care about. And if you don't have those things, don't do it. It doesn't mean you can't start to investigate and try things and learn by making mistakes, but don't think that a startup is an easy thing to do. That being said, this is the most rewarding thing I have ever done in my life, and many of the people that I've met the same. I think that you learn more than you possibly could in any other circumstance by running a startup, because you're exposed to such a broad set of circumstances and variables that you need to learn to control and understand, and you build your network faster than you ever could in any other situation.
You can learn more about Humm on their website at thinkhum.com. Think, HUMM.com. If you would like to be one of the first trial customers or be signed up and waiting for the final product to be shipped when it does, you can order it at thinkhum.com. If you have any feedback or questions, you can get in touch through the website. Humm is currently past its pre-seed round and is now raising $2 million seed round. Thank you for supporting this podcast, and please subscribe so you don't miss a new episode every Wednesday. You can also follow this podcast for regular updates on Twitter and Instagram at Sparklink Pod, all lowercase.